Hey guys, today we're going to be talking about graphing square roots and cubed roots. So first we're going to get started with the parent function of a square root, and we'll talk about graphing square root functions. So what's important to note when we're thinking about the parent function of square root functions is that we can't have any negatives under the square root, or else we're going to get imaginary numbers, which we can't graph. So we shouldn't include negative numbers for our input values of x. So I'm going to include positive numbers. I'm going to choose 0, 1. Usually we choose 2. And then I'm going to see where we're at and stop there. So if we input 0, we get the square root of 0, which is 0. If we input 1, we get the square root of 1, which is 1. If we input 2, we get the square root of 2, which is an irrational number. If you type it into your calculator, you're going to get approximately 1.4, which isn't super clean, and it's not going to be nice to do our transformations with. So instead of choosing the number 3, I'm going to go to 4 and 9 because those are perfect square numbers. When I substitute them in, I'm going to get whole numbers out. So if I put in 4, I get the square root of 4 is 2, and the square root of 9 is 3. So using numbers that are perfect squares are nicer than using numbers that aren't perfect squares because we get irrational numbers. So graphing this, I get 0, 0, 1, 1, 4, 2, and then 9, 3. So we're going to have an increasing graph, but it's increasing at a decreasing rate because it's steeper, but then it starts to kind of level out. But it's still going to be increasing forever and ever. So let's think about some function characteristics. So think about our domain and our range. Our domain, how far left we go to how far right we go. My leftmost point is 0 with a bracket, and my rightmost point is infinity because I have an arrow there. My range is very similar. My lowest point to my highest point. My lowest point is again 0, 0. So I go from 0 to my highest point. Even though this is increasing very slowly, it's still going up and up forever. So it's also to infinity. So now let's think about transformations, our A, H, and K values. I would like you guys to write down all of our options for A and what it does to our graph, vertical stretch, vertical shrink, those types of things, what values of A do that, our H value and our K value. What are we moving left? When are we moving right? So I'm going to pause the video here and have you guys try and fill that out on your own like we've done in the past. So you should have something that looks like this. When your A is greater than 1, you have a vertical stretch. When it's between 0 and 1, you have a vertical shrink or compression. When it's less than 1, you have a negative A value. That's when you reflect over the x-axis. When you have an H value that's positive, what it really looks like here, it's x minus H. So it's the opposite of what you think when it is in the skeleton here. So you shift right. When H is less than 0, it looks like x minus a negative. So it's plus H. So you shift to the opposite, you shift left. When your K value is greater than 0, you shift up, which is what you normally would think of. And then you shift down when K is less than 0. Something that's very important to remember is the order of our transformations. You always start with your H value transformation, whether you move left or right. Then you do your A value, and then you do your K value following order of operations. So your order matters. Example 1, we're going to describe the transformations from f of x is equal to the square root of x, which is we're going to compare our parent function to this, and then we're going to graph it. So I've written out our parent function, and so now let's list our transformations, and we're going to also list them in order. So we're going to start with our h value. Our h is equal to 3. So that means we are shifting to the right, the opposite of what we think. So we're going to go right 3 units. Now let's think about our A value. Our A value is 2. So that falls into the category of a vertical stretch. by 2. And then finally, we'll think about our k value, which is negative 2. So that means we are going to shift down 2 units. And what we do for our transformations is we take the x values of our parent function, and since we're moving right 3, we add 3. When we're dealing with the vertical stretch and shifting down, that deals with our y values. So first we're going to multiply our y values by 2. Then we are going to end up subtracting 2 from them. So let's perform our transformations. So we are adding 3 to 0, to 1, to 4, and to 9. And this is going to go slightly off our coordinate plane here, but that's okay. Here we're going to multiply by 2 and then subtract 2. 0 times 2 is 0, minus 2 is negative 2. 1 times 2 is 2, minus 2 is 0. 2 times 2 is 4, minus 2 is 2. 3 times 2 is 6, minus 2 is 4. So here are our new values. And then we graph them. We go to 3, negative 2, 4, 0, 7, 2, and then 12, which is just slightly out, 4. Oops, 4 is a little bit higher. And there is our new graph of g of x. I would like you guys to try this one on your own. List the the transformations from the parent function, and then fill out your new table in comparison to the parent function. You probably need to jot down what your parent function is, and then perform the operations, and then graph it. Pause the video here and give it a go. Here is example 2, your transformations. You're going to need to subtract 2 from your x values, multiply your y values by negative 3, and then add 3. And you're going to get these coordinates, which you can graph. Moving on to the parent function for cubed roots. Similarly to our parent function for square roots, we chose numbers that were perfect squares. Here we're going to pick perfect cubes. That way we can get whole numbers and not have to worry about irrational numbers in our table, which get a little bit messy. So the other thing to think about is that we can have negative numbers now, because we can have the cubed root of a negative number and still get a real number out that's not imaginary. So I'm going to think about my perfect cubes, and I'm going to have, let's just think of 0 cubed. I'll include 0. I'll put that in the middle. 1 cubed is 1, so that's a perfect cubed. 2 cubed is 8, and that's a perfect cube. So I'm going to include that. And then I'm kind of almost off my coordinate plane if I go any further in that direction. Well, I also have the same numbers but negative. I have the cubed root of negative 1 is negative 1. The cubed root of negative 8 is negative 2. And it all works out very nicely from here. So here is my parent function table for cubed roots. And cubed roots look very similar to cubics. However, instead of continuing to increase rapidly, we're going to look slightly different. We're going to be turned on its side. And so this is what my cubed root looks like. Again, very similar to a cubic, just turned sideways. And you can also see that similarity to quadratics with the square roots, because it's just a parabola turned over on its side, and which is why we only have half of it, because if we had the other half of the parabola, it wouldn't be a function. So now I would like you guys To try this one on its own, I want you to describe the transformation from its parent function, which should be the cubed root. So use your parent function table, describe the transformations, and perform the transformations. Pause the video here. So for this example, we shift right 3, we are stretching by 2, and we're shifting up 5. So we get these new coordinates after we add 3 to our x values, multiply by 2, and then add 5. And we get something that looks like this. Something to take note is if you look at the points directly to the right and left of your kind of center point, and it's the same kind of center point, your HK value that we've seen in the past, is you can see your stretch of your A value because you go up to right 1. And you can see that also with our square root functions where you have your starting point instead of like your center point. And here our A value was -3, but we went down 3, right 1. So just to show you, it's still there. Even when we have different functions, you can still see that transformation of the A value. Speaking of that center point, that HK value, that's going to be super helpful for us to be able to write a cube root function, or knowing where we start, that starting value for a square root function, to be able to write a square root function. So here we're going to be writing a cubed root function, and we're still going to be using this vertex form where we have that center point. So here, this reference center point is at -2, 1, 2, 3, 4, 5. So -2, 5. So this is giving us an H value that's -2 and a K value that's 5. So far, we already have a majority of our equation. So we have g of x is equal to a, which we don't know yet, is the cubed root of x minus a -2, so +2, and then +5. And then we just need to find our a value. We can be very careful and find our a value by looking to the point directly to the right, 1 unit to the right, and then counting the slope by going up to right 1 and finding that the a value is equal to 2. And then we can substitute it in. But if you're not comfortable, especially when you get fractional a values, it can be a little bit unclear. We can actually also just pick a point that's not the center point and see what we get for a by substituting in that value. So I'm going to take, let's take this point that we picked directly next to it. So that's the point -1, -3. And I'm going to substitute it in for g of x and x. So g of x is the same thing as y, so I put in -3 here. It's equal to a, the cubed root of x, which is -1, +2, +5, and then I'm going to solve for a. So solving for a, first I do what's in the cubed root, and I get the cubed root of 1. The cubed root of 1 is just 1. From here, I subtract 5 on both sides. And realize I'm not getting an a value of 2, and I realize Ms. Marshall made a silly mistake. This should be -2, -5, so that should be minus, 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 plus, plus, and then I'm getting my a value of 2, which it should be. So be careful there with your negatives. Don't make silly mistakes like Ms. Marshall. So then I can put it all together and get g of x is equal to 2, the cubed root of x, plus 2 minus 5. Please be very careful when you're writing this by hand that this index number of 3 is written small enough so it doesn't look like 23 times the cubed root of x plus 2. Make sure you write it small and in its little cubby. That's all I have for you guys today. Make sure you ask questions if you have them. Have a good one, guys.